What's up, everybody, and welcome back to another math puzzle. In this one, the question is as follows. Find the area of the quadrilateral, meaning this quadrilateral right here. And by the way, this entire figure is a square. And not only that, all of these segments, this segment, this segment, this segment, these are all equal. Last but not least, we got the areas of these other quadrilaterals. In the giant quadrilateral, we have 84, 68, and 60. Hit that pause button and see if you can figure it out. When you're ready, hit play and I'll give you the explanation. All right, to solve a puzzle like this, we're gonna need to draw in some additional lines. In particular, we're gonna need to create some triangles. So I'm gonna do that first. So what I did is I drew in a line segment from every vertex to this center point right here. And what that created is 1, 2, 3, and 4 different triangles. Now, the interesting thing about these triangles is they all have the same base, at least on a particular side, right? Here, these two both have the same base. They're both equal, and they both have the same height. The height is going up to this top vertex right there. And why is that important? Well, if you have two triangles with the same base and the same height, okay, whether it's external or internal, those triangles are going to be equal. Okay, so that means that this triangle and this triangle are going to be equal in area. So I'm going to call them both A. Then over here, we're going to have the same dynamic on this side, right? This triangle and this triangle, they're both going to have the same base and also the same height. They're going to be equal. I'm going to call those triangles B. Up top, we're going to have the same dynamic. This triangle and this triangle, they're both going to have equal areas. I'm going to call them C. And then last but not least, these guys here and here, they're going to have the same area as well. I'm going to call them D. And now with these different letters, I'm going to make some equations. So first of all, we've got A plus B. Well, I know what that is because that's that quadrilateral in the corner that is 68. B plus C is right here, and that's going to add up to 84. Then we got C plus D. That's our question mark. This is what we want to solve for, C plus D. And then last but not least, we got D plus A, which is equal to 60. So now we're going to use a little bit of algebra. I'm going to actually combine these two equations. That's a nice system. Let's combine them. First one I'm going to do is I'm going to negate this equation. I can always do that with any equation. I'm going to multiply everything by -1. So we're going to have negative A minus B is equal to negative 68. Then I'm going to add that to this equation, which is B plus C is equal to 84. So if we add these together, the B's are opposites. They're going to cancel out. So then what I'm left with is, let me write it up here, C minus A is equal to 84 minus 68, and that's going to be 60. Okay, so this is really special because now I have C minus A is equal to 16. Let's bring that down here. C minus A is equal to 16. Well, look at this. Now I can add these two equations together, and the A's are going to cancel out. A plus negative A is nothing, and then we're going to get C plus D, positive C and positive D. That's what we're trying to find in the first place. So now I have this amazing equation. I have, let's write it up here. I'm running out of room here. We got C plus that D with the A's canceling out is equal to 60 plus 16. That is 76. And so there you go, 76 for the win. That's the area of this quadrilateral. That's how you do it. Done. I hope you guys enjoyed this math puzzle, and if you did, please click that like button. If you want to see more math puzzles on the regular, make sure to click subscribe. Thank you guys so much for joining. See you in the next video. Take it easy.